All right. Question says, how do drugs produce a their pharmacological response? So you talk about receptor and non-receptor. So receptor-mediated ones are receptors bound to the drug effect. So you have the ligand bind, which is inotropic. So we take over allosteric and orthosteric. So allosteric is at a different site, like the GABA. Orthosteric is at the same site, like Sax. Conformation will change the ion channel, open and close, leading to an influx of ions. Then the G protein coupled receptors, the 7-transmembrane serpentine heteromeric intracellular G protein coupled with alpha, beta, gamma subunit. You have the N and the C inside. Extracellular ligand binding site. The ligand binds to GDP alpha and becomes GTP alpha, separates from the beta gamma, and then causes second messenger effects of the G protein coupled receptor. You also have NORAD, which has the GS protein coupled receptor, increase adenyl cyclase, and CAMP, but also has the presynaptic phosphorylation of the IF channels, increases dromontropy. Then you have the tyrosine kinase, and the way I remember tyrosine kinase, I remember Tarek, and I remember he's like this guy called Tarek, and he's on a map, right? He's holding a map, sorry, and he's climbing a mountain. Why do I remember that? Because you have map K and PI3K. So peak of the mountain and map K. So tyrosine kinase is for the insulin. So ligand binds to the tyrosine kinase 2 alpha 2 beta, and the receptor autophosphorylates. The intracellular second messenger, insulin receptor, for example, binds to T that, or the autophosphorylase second messenger via the MAP and the PI3. And it has an anabolic effect. Then you have intracellular stuff, so that's diffusion. It diffuses into the cell and binds to the intracellular, transports nucleus, and exerts effects such as the um, outer gene. And then you have non-receptor, which is a direct act on the ion channel. So, like local anesthetic binds to the voltage-gated sodium channel.